In this episode, we're going to focus on a problem that makes cloud security feel unpredictable even when people believe they built things correctly, which is configuration drift. Drift is what happens when the environment slowly changes away from the secure baseline you thought you had, often through small, reasonable decisions that accumulate over time. Someone opens a network rule temporarily to fix an outage, a team grants a broader permission to unblock a deployment, or a developer changes a storage setting during troubleshooting and forgets to revert it. None of these actions may feel dramatic in isolation, but together they create an environment that no longer matches the intended design. Policy as code and continuous posture enforcement are the methods that keep the environment anchored to known good expectations even as it changes. Instead of relying on periodic audits and human memory, you build automated guardrails that notice drift and push the environment back towards safety. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good starting point is to make drift feel concrete, because beginners often imagine configuration as a set of static settings that stay put once deployed. In cloud environments, configuration is dynamic because infrastructure is constantly updated, scaled, rebuilt, and integrated with new services. Even when teams use infrastructure as code, IAC, drift can occur because people still make manual changes in consoles, automation scripts adjust settings, or providers introduce new default behaviors. Drift can also happen because different environments evolve differently, leaving development more permissive than production or leaving one region with older security rules than another. The danger of drift is not just that settings change, but that they change without visibility and without consistent intent. When intent is lost, security becomes reactive because you only discover the drift after it causes exposure or breaks something. Policy as code is the idea that security and compliance expectations should be expressed in machine-readable rules rather than in formal documents or tribal knowledge. Instead of saying that storage must not be public as a guideline, you define a policy that can evaluate whether a storage resource is public and deny or flag it when it violates expectations. When you first hear policy as code, think of it as converting security rules into executable logic that tools can apply consistently. This makes security expectations testable, which means they can be evaluated automatically during deployments and continuously afterward. Beginners sometimes think policies are only for auditors, but policy as code is for engineers because it provides clear, enforceable definitions of what acceptable looks like. It turns security from advice into a measurable requirement. One of the most important benefits of policy as code is that it reduces ambiguity, because humans interpret guidelines differently, but machines apply rules consistently. If a policy says that public access is prohibited unless explicitly approved, that rule can be applied the same way every time, regardless of who is deploying. This consistency matters in cloud environments where multiple teams may build resources using different tools and different workflows. Without consistent rules, each team may choose slightly different security settings, creating an uneven posture. Policy as code becomes the shared language that aligns behavior across teams. It does not eliminate the need for judgment, but it creates a baseline that prevents accidental drift from becoming normal. Continuous posture enforcement is the second half of the solution, because policies alone are not enough if they are only checked occasionally. Posture refers to the current security state of the environment, meaning whether configurations match your intended baseline. Continuous enforcement means evaluating posture regularly and responding when violations appear. This response can include alerting, blocking changes, or automatically remediating settings back to compliant values. The key beginner takeaway is that security posture is not a one-time achievement, because cloud environments change constantly. Continuous evaluation turns security into an ongoing process that detects drift early, when it is easier to fix and less likely to become a serious exposure. A beginner misunderstanding is assuming that continuous enforcement is the same as constant disruption, as if every small deviation will immediately break deployments. In practice, effective posture enforcement is designed to be risk-based and context-aware. Some violations may trigger immediate blocking because they create high risk, while others may trigger warnings and require approval for exceptions. The point is not to prevent all change, but to ensure change stays within controlled boundaries. When enforcement is tuned thoughtfully, teams can move quickly while still avoiding the dangerous habit of leaving temporary exceptions in place. Continuous posture enforcement supports speed by preventing chaos. Policy as code connects naturally to infrastructure as code because both are about making intent explicit and reviewable. When you deploy infrastructure with IAC, you can evaluate the proposed changes against policies before they are applied. This catches risky configurations early, reducing the chance that unsafe resources reach production. It also creates a feedback loop where teams learn secure patterns as part of their development process. Beginners sometimes think security checks slow down deployment, but early checks often save time because they prevent later incidents and rework. When policy evaluation is automated, it becomes a normal part of how changes are made. This integration makes security both repeatable and testable. Another important dimension is coverage, meaning policies should address the configurations that most commonly cause exposure. These often include public network access, overly broad identity permissions, unencrypted storage, and missing logging. Policies should also consider relationships between resources, not just individual settings. For example, a database might be private, but if it is reachable from a public-facing subnet without proper controls, the system can still be exposed. Beginners sometimes focus on single settings, but drift often happens through combinations that create unintended access paths. Policy as code can express these relationships and evaluate them systematically. The more accurately policies reflect real risk pathways, the more valuable enforcement becomes. Exceptions are inevitable in real environments, which is why exception handling must be part of drift prevention rather than a loophole that undermines it. A secure approach requires explicit approvals and documented justification when policies must be bypassed. Time-bounded exceptions prevent temporary workarounds from becoming permanent drift. Without time bounds, exceptions accumulate, and the baseline erodes slowly. Policy as code systems can enforce expiration on exceptions and require renewal if the need persists. This keeps deviations intentional rather than forgotten. Beginners often overlook that drift is frequently the result of forgotten exceptions, not deliberate insecurity. Continuous posture enforcement also benefits greatly from clear ownership because someone must be responsible for responding when policies detect violations. If alerts are generated but no team owns remediation, enforcement becomes noise. Ownership ensures that policy findings translate into action, whether that action is fixing configurations, adjusting policies, or formally approving exceptions. This also supports accountability across teams, because the environment's posture is a shared responsibility with defined roles. Beginners sometimes assume automation removes the need for people, but automation changes the nature of the work rather than eliminating it. People still decide what acceptable looks like and how to respond when reality deviates. It is also important to understand the role of drift detection versus drift correction. Detection means identifying that the environment no longer matches the baseline, while correction means actively restoring the baseline. In some cases, automatic correction is appropriate, such as disabling an unintended public endpoint immediately. In other cases, automatic correction might break a legitimate workflow, so alerting and review may be preferable. The balance depends on risk and business impact. Beginners may assume correction is always better, but thoughtful enforcement uses both approaches. The goal is to reduce risk without creating unnecessary outages. Drift can also occur through changes that are not directly made by your teams, such as provider updates, new service features, or changing defaults. For example, a new feature might introduce additional access paths that were not previously considered. Continuous posture enforcement helps here by re-evaluating the environment as it evolves, rather than assuming yesterday's baseline remains valid. Policies can be updated as new risks emerge, and the updated policies can then evaluate existing resources for new violations. This prevents the environment from becoming outdated relative to evolving platform capabilities. Beginners sometimes assume cloud providers handle security by default, but your posture depends on how services are configured and how those configurations evolve over time. An important benefit of policy as code is that it encourages learning and consistency because teams see the same rules applied repeatedly and begin to internalize secure patterns. Over time, fewer violations occur because developers and operators understand what will be rejected or flagged. This reduces friction and increases speed because secure configurations become habitual. It also improves collaboration because policy discussions become about specific, testable rules rather than vague disagreements. When a rule is clear, teams can debate whether the rule is appropriate and adjust it deliberately. Security becomes a shared engineering conversation rather than a last-minute gate. That cultural shift matters as much as the technical tooling. By the end of this episode, the central idea should feel straightforward even for a beginner because it is about keeping a moving system aligned with its intended design. Configuration drift is inevitable in cloud environments because change is constant and small exceptions accumulate quickly. Policy as code turns security expectations into executable rules that can be tested and applied consistently. Continuous posture enforcement evaluates the live environment repeatedly, detects violations early, and responds through alerts or remediation. Exception handling keeps deviations intentional and time-bounded rather than forgotten and permanent. When these practices work together, your cloud posture stays stable even as your infrastructure evolves, and security becomes a repeatable outcome instead of an ongoing mystery.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.